Okay, so this is lesson number 3 in this unit. What we're going to do today is get into factoring polynomials. Now, you should know how to factor trinomials already. We've been doing this for a little while, so let's take a look at some of these. Quick review. Hopefully by now you're pretty comfortable with using a guess and check model. So I know that 2x times 3x is 6x squared, and using that negative 3, I think if I put a plus 3 here and a minus 1 here, you're going to get the right factor. Let's just check that. So 6x squared minus 2x plus 9x, yeah, that works. Okay, let's try this next one. Here you can see there's a common factor. Remember, you should always look for a common factor first. A lot of times, if you find the common factor, it's going to make factoring much easier. Okay. So again, 2x times x is 2x squared. How do I get to negative 14? Well, negative 7 and positive 2. Let's see if that works. So I'll put a plus 2 here and a negative 7 here, and I think that factors. Okay, and this one, I don't know if you should be able to recognize this. This is difference of squares. You can see that's a perfect square, that's a perfect square, and there is a minus sign here. If you have a minus sign with perfect squares, you can factor this using difference of squares. So you'd have 7x, 7x, 6y squared, 6y squared. This one's positive, this one's negative. Okay, so quick review of factoring. You will still need to be able to do that, but what we want to do is factor polynomials, not just trinomials. Okay, could be more than 3 terms. All right, how are we going to do that? Well, there's a couple little tricks we need. First of all, let's recall this from yesterday, long division. I'm looking at that and I'm going, hey, it would be easier to use synthetic division. So let's synthetic divide this. A quick little review of that. Bring the 5 down, multiply, add, multiply, add, multiply, add. There's your remainder. Okay, what does it mean if there is a remainder? Well, it means it didn't divide evenly. There's something left over. What we want to be able to do is find factors of these polynomials. So we want to have remainders of 0. Well, here are a few tools we can use. All right, in that example, we divided x minus 2 into this polynomial. All right, and we had a remainder of 47. Look what happens if we do this. If we take this value of 2, which was our a value, if you remember, and put it into the polynomial. Okay, sometimes if you don't want to actually divide, turns out this is going to be a bit of a shortcut. So 2 cubed is 8 times 5 is 40 minus 2 squared is 4 times 2 is 8 plus 16 minus 1. What does this equal? 47. So take a look at that. The remainder when you divide is 47. What you get when you put 2 into the polynomial is 47. All right? This is called remainder theorem. And it's a little shortcut that you can use if you're trying to find out if x minus 2 is actually a factor. Okay? Remainder theorem says when you have a polynomial p of x, if you divide by x minus a, you can just figure out what p of a is, and it'll give you that remainder. Okay? So let's try a few of these. So let's say we were wanting to know, is x minus 3 a factor of this? Well, we could go p of 3 and put it into the polynomial. What does this equal? Well, 3 cubed is 81 times 2 is 162. Minus 3 cubed is 27 times 5 is 135. 3 squared is 9 minus 45 plus 15 plus 3. What does this equal? Well, let's add up the positives. So 162 plus 18, that's 180. And if I add up the negatives, this turns out to be 180. So there is a remainder of 0 when I divide x minus 3 into this polynomial. That means x minus 3 is a factor. It goes in evenly. Okay? Let's try x plus 2. See what happens when it is divided into there. By the way, if you prefer, you could use division. Okay, there's nothing wrong with doing that. If you think that's more comfortable, you could do that. I would like you to learn this method, but you don't need to do it if you're given the choice. Okay, so this is 32. We have negative 8 plus 40 minus 20 minus 10 plus 3. All right, if we add the positives, we get 32, 72, 75 minus 30. The remainder is 45, so this is not a factor. Okay? So using remainder theorem kind of leads to factor theorem. If we have a remainder of 0, it's a factor. Okay, so looking back up here, this is a factor. This is not a factor. Okay, so take a second here and try to see if any of these 4 are factors. Okay, so we can pause the video and then come back and I'll do it. So x plus 1 is a factor. So x minus 3 is a factor. All right. So this is negative 64. 6 times 16 is negative 96. Negative 20 plus 12. This is negative 180 plus 12, so negative 168. So that one's not a factor. So when you do these questions, be careful with your negative signs. All right? You need to make sure that you do your powers first. And a lot of times if there's an even power, the negatives are disappearing. Okay, careful you don't do negatives before you do the powers. All right, like if you looked up here, don't think you can cancel this negative and this negative. Okay, you can't because the first negative will be squared and turn positive first. Okay, this is 96 plus 20 plus 12. So this is 0. All right. So we have some tools. Why do we want those tools? Well, what we want to be able to do is factor stuff like this. And we don't have the skill to just do something like this. Say, hey, I can guess what those three factors are. You know, sometimes maybe you could, but that's not the method we're going to use here. Instead, what we're going to do is try to figure out, can I find one factor? And once I find one factor and divide, then I can factor what's left over, sort of the way we used to do it. Okay, so what we want to do here is we want to figure out what is a factor. You know, does x plus 2 go into there? Does x minus 3? What goes into there evenly? Okay, couple of clues. Here's the big one. If I know that these three factors, when multiplied, equal this, my last numbers would have to multiply to equal 6. So that's kind of where I'm going to base my guessing from. What multiplies to give me a 6? All right, I know that plus or minus 1 would go into 6 evenly. Plus or minus 2 would work. Plus or minus 3. Plus or minus 6. Now, there are fractions and decimals that would work, but I'm going to stick with what's easy. I'm going to pick one of those numbers. So, let's try, well, the very first one would be x minus 1. All right, and so what I'm going to do is I'm going to say, let's take p of 1 and put it into here and see if that's going to give me a remainder of 0. If it is a remainder of 0, it's a factor. So I'm going to go 2 times 1 cubed minus 9 times 1 squared plus 7 times 1 plus 6. What does this equal? 2 minus 9 plus 7 plus 6. What's that equal? 8. So this is not a factor. No good. Okay, so maybe I'll try x plus 1. Now sometimes you're going to get lucky. Sometimes you're going to find a factor right away. Sometimes it's going to take you a little bit of a longer fight. Okay? And sometimes you may say to yourself, you know, I don't want to write this all out. Maybe I could just do it mentally until I find one. That's totally acceptable as well. In fact, I think you're probably going to want to do that, because writing this all out repeatedly, if it's not working, is kind of painful. Okay, so I finished that one. It still didn't work, so I'm going to try x minus 2. So p of 2 so here you're going to get 16 minus 36 plus 14 plus 6, and that equals 0. Yay! Success! So, this means x minus 2 is my first factor. So if I take the polynomial, here it is, I know that one of the factors is x minus 2. What I need to do is figure out the other ones. So to do that, I'm going to actually divide by x minus 2 now. Hey, we know how to do this. All right, I'm going to take 2 and divide it into this polynomial. And I know that my remainder is going to be 0 because it's a factor. So let's see what happens. There it is. Remainder is 0. So that means what's left over? 2x squared minus 5x minus 3. And what I want to do is factor this further. All right, and what do you get? X minus 2, yeah, that's the first factor. And then I can put 2x here, x here. This is going to be minus 3, this will be plus 1. And there is fully factored polynomial. Okay? Let's try this one. I'll give you a few minutes to try it, and then we'll factor it together. Okay, easier. I only have to try plus or minus 1, plus or minus 2. So let's try x minus 1. So p of 1 is 3 times 1 cubed minus 4 times 1 squared minus 5 times 1. It's 2, so 3 minus 4 minus 5 plus 2. No good. Let's try x plus 1. Negative 3 plus 4 plus 5 plus 2. Wait, no, that's wrong. I made a mistake. This was squared. So this is going to be minus 4 plus 5 plus 2. And that is 0. Yes. First factor. So 3x cubed minus 4x squared minus 5x plus 2 equals x plus 1 times what? Well, to do that, I have to divide. So I'm going to take negative 1 and divide it into the polynomial. So I get 3x squared minus 7x plus 2. And I should be able to factor that now. I think we'll have minus 2 minus 1. There it is, factored. Now, if you'll notice, every question we've done so far has been x cubed. If that was x to the 4, we would end up with 4 factors. And so you would have to repeat some of these steps. Okay, we will have some of those to try in our homework. All right, we'll stop there for now. Okay, in the homework, page 20. And you can try a few on page 29 as well. Actually, let's change that 1 to 7. If you by chance need help, if you're struggling on how to do something, let's start by sending me an email. Send me a picture of what you're stuck on. I'll see if I can help you, and we'll start that way. All right? Good luck. Keep checking for updated lessons.